Why else would we stop? I mean, the ball is still rolling, so let's keep going. First and foremost, a quick reminder, in the last video of this series, we were sketching the graph of f of x is equals to 2 to the power of x plus 1 plus 1, right? This is the graph we sketched where the asymptote was cutting the y-axis where y was equivalent to positive 1, right? And the graph itself was cutting the y-axis at what? Y is equals to 3, with the graph not having an x-intercept, right? And then we plotted two other points where x was equals to 2 and y was 5, x was equals to 3 and y was equals to 9, I believe. That's the shape of a graph we determined. And how did we get there? We were following a series of these steps, right? If you didn't see that video, please go and watch the previous video in this specific series. It'll put you up to speed, right? So we determined the asymptote, y is equals to 1. Okay, and the shape, it's gonna be increasing from left to right, seeing as our b is greater than 1, right? The x and y intercept, we determined that there's no x-intercept, and then y is equals to 3. At least two other points that we got the point. We sketched the graph. This is the graph we had, and now we have the exact replica of the graph of y is equals to 2 to the power of x plus 1 in here. This is the same graph we had. It's this exact replica. Y is equals to 1. Y is equals to q, because this q in our standard form. Remember that q in our standard form, right? So why the q? Why am I talking about the q? That is to address the matter of the range. What is a range? The literal definition for a range in the subject of mathematics is a set of y values, right? So a set of y values, we are dealing with the y-axis. The range of an exponential function where a is positive in the standard notation is a positive 1. It's gonna be ranging in a direction where y is greater than q. In this regard, y is equals to 1. Our q is equals to 1. So that is to say, our range for the specific graph of f of x is equals to 2 to the power of x plus 1 plus 1. The range for this graph is y is greater than q. Y is greater than 1. Q is equals to 1 in this graph. That's how we would determine our range. As for our domain, for an exponential function, it's a counter solve for us. X element of real numbers, x element of real numbers, x element of real numbers. Of course, with the specific exception of inverse function, where it's gonna be a slightly different inverse relationship as to how we define the domain and range, right? That's something for the grade 12s, and the rest of you need not worry about that.